Hello and welcome. Today, I'm excited to share with you a groundbreaking discovery in the world of science, a new way to fight cancer. We'll dive deep into this topic and explore why this discovery is so important and what opportunities it brings for humanity. A team of international researchers has developed a revolutionary new method to treat cancer. This approach involves reactivating dormant metabolic pathways in cancer cells to combat the disease. The team used a common amino acid called tyrosine, delivered through nanotechnology to target and inhibit the growth of melanoma, one of the most serious forms of skin cancer. Cancer is one of the greatest challenges in human history, manifesting in various forms, each with its own treatment difficulties. Melanoma specifically occurs on the skin and is particularly prevalent in Australia, which has the highest rate of skin cancer in the world. This makes new treatment methods developed here incredibly significant globally. Australia's high skin cancer rates are a major public health issue, largely due to intense sun exposure. This new method can be combined with existing treatments to fight melanoma more effectively. Moreover, it has the potential to be applied to other types of cancer as well. This study, led by Professor Wenbo Bu from Fudan University and Professor Dayong Jin from the University of Technology, Sydney, was recently published in the prestigious journal Nature Nanotechnology. Tyrosine has limited bioavailability, but researchers have packaged this amino acid into tiny particles called nanomicelles, which are attracted to cancer cell membranes and break down easily, enhancing absorption. This innovative treatment was tested in mice and human-derived melanoma cells in the lab, where it was found that tyrosine nanomicelles reactivated dormant metabolic pathways, triggered melanin synthesis, and inhibited tumor growth. Professor Jin explains, "A key characteristic that distinguishes cancer cells from normal cells is uncontrolled rapid growth. In cancer cells, some metabolic pathways are overactivated, while others are suppressed to create the environment necessary for rapid spread." Professor Bu adds, "Our research shows for the first time that cancer can be stopped by reactivating metabolic pathways that are dormant, and this can be done using simple nutrients such as amino acids, sugars, and vitamins, which are safe, readily available, and well tolerated." Different types of cancer respond to different nutrients. Melanoma cells develop from melanocytes, the skin cells that produce melanin. Tyrosine is necessary for melanin production and can stimulate melanin production, hence its effectiveness against melanoma. Reactivating melanin synthesis forces the melanoma cell to reduce glycolysis, the process of converting sugar to energy, which is believed to be the mechanism behind its anti-cancer effect. Melanoma cells are also sensitive to heat stress. Researchers found that combining tyrosine nanomicelle treatment with near-infrared laser treatment eradicated melanoma in mice after 6 days, with no recurrence during the study period. These findings open a promising new frontier in using nanomedicine for cancer therapy. Understanding how this innovative treatment works and what benefits it can provide for human health requires a look at the work of scientists in this field and previous research. Traditional cancer treatments often focus on suppressing or eliminating tumor growth. However, this new approach targets cancer cells directly and reactivates their metabolic pathways, offering a different strategy. Looking at the history of cancer treatment, the role of metabolic pathways has been a subject of research for a long time. Metabolic pathways regulate the processes through which cells produce and use energy. Cancer cells have different metabolic needs than normal cells to support their rapid growth and division. Therefore, regulating these pathways is seen as a crucial strategy in cancer treatment. For example, some metabolism-based drugs like aromatase inhibitors work by blocking estrogen synthesis in breast cancer, while HK2 inhibitors target glycolysis in various cancers. However, these drugs typically focus on suppressing overactive metabolic pathways. The research by Professor Bu and his team shifts this paradigm by showing that reactivating dormant metabolic pathways can be effective in cancer treatment. Many renowned scientists have provided valuable insights into the role of metabolic pathways in cancer treatment. For instance, the famous physicist and science communicator Michio Kaku has frequently highlighted the potential of nanotechnology in cancer treatment. Kaku emphasizes that nanotechnology can deliver targeted treatments to cancer cells, and such innovative approaches could revolutionize cancer therapy in the future. Similarly, Nobel laureate James Allison has researched the role of the immune system in fighting cancer and demonstrated how immune checkpoint inhibitors can be effective in cancer treatment. Allison's work shows how targeting the mechanisms cancer cells use to evade the immune system can lead to their destruction. This is another example of how innovative approaches, like reactivating metabolic pathways, can be highly effective in cancer therapy. This new treatment method has the potential to be used not only for melanoma, but also for other types of cancer. Different types of cancer have different metabolic profiles, allowing for the development of personalized treatment approaches. For example, some cancers are dependent on certain amino acids or other nutrients. By targeting these nutrients, it may be possible to halt the growth and spread of cancer cells. This treatment method can also be used to reduce the risk of cancer recurrence. One of the biggest challenges in cancer treatment is the development of resistance and recurrence of tumors. However, reactivating dormant metabolic pathways can target the survival strategies of cancer cells, potentially overcoming this resistance. These exciting developments open the doors to a new era in cancer treatment. Innovative approaches like nanotechnology and the reactivation of metabolic pathways offer more effective and targeted treatment options. Such treatments will not only improve the quality of life for patients, but also lead to better outcomes in cancer therapy. The future of cancer research looks incredibly bright. As new technologies and treatment methods are developed, more progress will be made in the fight against cancer. Collaboration among scientists and researchers, sharing knowledge and resources, will be crucial in this process. Science and technology have played a key role in solving many of humanity's problems, and cancer treatment is one of these challenges. These significant discoveries made in the light of science bring new hopes in the fight against cancer. Don't forget to subscribe to our channel and turn on notifications to stay updated on these exciting developments. See you in the next videos. Stay healthy. In conclusion, reactivating dormant metabolic pathways in cancer treatment stands out as a groundbreaking discovery in the world of science. This innovative treatment method shows great promise not only for melanoma, but also for other types of cancer. With the collaboration of scientists and researchers, such innovative approaches will lead to more successful outcomes in the fight against cancer. We are proud to witness the power of science and the determination of humanity once again in this process.